Hello friends, this is JBrains again. Today I'd like to introduce a new exercise, a fun exercise, and one that will, I hope, lead to some more interesting problems and will form the basis for a lot of the work that we're going to do in the rest of this course. So the story goes like this. I'm trying to open a retail store. I'm already behind schedule. In fact, every day that I don't open, I'm losing hundreds of dollars. Fortunately, it's still only hundreds of dollars per day. I have inventory waiting that I'm trying to sell. I have space moved in, everything set up, but I don't have my point of sale equipment. And that's what I need you to build for me starting today. I hired my idiot nephew 6 months ago, and he promised that he was going to take care of this for me, and there's a reason that he's my idiot nephew. Like most programmers I've worked with, he worked for 6 months. Didn't show me anything, told me everything was fine, and when I told him it was time to open the store, he said, I have nothing working. So I need you guys to do better. Now, I'm not coming at this with completely nothing. I've actually thought about this problem an awful lot over the 6 months as I've been watching my idiot nephew not finish anything. And I know I can at least get to the point where I can operate my store on a very, very basic level with just one feature, and that's the feature to sell a single item. 85% of my store's sales are a single item per customer. It's not like a grocery store. It's more like an electronics store or some kind of high-end retailer. It's like that. So most of what I sell is a single item at a time. All I really need is to be able to sell a single item to each customer. In fact, I can live with the fact that if somebody wants to buy 3 items, that I have to ring them through 3 times. That's how desperate I am for a point-of-sale system that does something. Now, I have a little bit of hardware to help out. In fact, the very first piece that I have is this cute little guy right here. This is called the QCat. This is a $15 barcode scanner that was originally designed to scan barcodes for books to use in library things. But with a one minor hardware change, it becomes a general purpose barcode scanner that you can use, and it works just like a keyboard. So let me give you an example. I happen to have a product over here. This is these are express post envelopes. For my non-Canadian viewers, these are essentially envelopes that you can send through the mail express from Canada Post. And you can see that we have a barcode right down here. So if you take a look at the barcode on your screen there and at the terminal prompt that I have open here as well, watch what happens when I try to scan the barcode. So you can see, of course, that it's not a valid Z shell command, but you can see that the QCat behaves essentially the same as if I had punched in the barcode 06349102812 in on the keyboard and press the enter key. So the QCat's pretty simple. It works just like a keyboard device, so it should be no problem to integrate. The other part of the equation is this handy little USB-based LCD. So this is an LCD from a company called Crystal Fonts. It's a 4-row by 20 column LCD. It plugs in by USB, but it talks over a serial port. So all you have to do is install a USB serial port device driver on your computer, which I've done from a company or an organization called FTDI, and I can actually use this. If I take a look, if we flip over to the computer here, and I look in the device directory, when I plug this guy in, there's a device called dev.tty.usb serial-cf006760. Now, I don't know about the CF006760 part, but the important thing is that this is an output that I can use to send messages over a serial port. And what I've done is written a little bit of Ruby code that does exactly that. And I have this running right now as either a UDP server or an HTTP server using Sinatra. So you can take a look inside the code if you like, just a very quick look inside. This is pretty much the entire code. This is actually sending a message to the display. The open method opens a connection to the serial port over that device at 19,200 baud. Whenever you clear the display, we essentially write 80 spaces to the display. It's the same as clearing it. And when we write to the display, that first line sends 1700. 17 is the code for the next two characters represent the coordinates where I want to display a message. So I just assume that every message wants to be displayed in the top left corner, that's 00, and then we just write out the text. And it's really that simple. So clearing the display, writing to the display, printing a message, this all looks pretty simple. As I said, I have made both a UDP and an HTTP server interface around this. So in fact, if I go back here and then make sure that I have everything installed, I definitely need a serial port, the serial port gem installed in Ruby in order to make this work. Now I can run shotgun, and that will create this nice little web form over port 9393. And there we are. So the nice thing about this setup is that all I have to worry about right now are the inputs and the outputs, and everything's a string. So it should be relatively easy to implement the first feature. So let's just create a couple of simple boundaries to make it easier for you to get started. So the job of the first feature is I want to be able to sell a single item. So the simplest thing I can think of to get started is scan the product code, and the correct price, at least the correct price, shows up on the LCD. That's a good enough place to get started. In fact, that architectural spike helps me understand, or helps me show, that I can handle real-life input from the real hardware. I can put real-life output to the real hardware. And if I can put a price on the hardware, then it should be relatively easy to add things like product information, a short description of the product. When we add things like multiple quantity, it'll be relatively easy to add, 3 at $7.95 and then show $23.85 right underneath. The first thing I need to do is show that I can scan a product and the correct price shows up. If I do that, then the rest should be relatively easy. I can add whatever bells and whistles I want. So let's do some high-powered diagramming here. This is the thing that you're building. It's the big cloud of I don't know what. And of course, we need to worry about the output. And the output is going to be some text on a display. So by text, of course, I mean a string. So you're going to display, let's say, $11.50. What matters is a string comes out. You have to think about how you're going to check, where you're going to send that string, and how you're going to check it. On the other side, on the input side, of course, we have a barcode coming in. Now, the beautiful thing about the barcode scanner is, remember, it simulates typing a barcode and pressing the enter key. So we can assume that the barcode coming in, for example, is like that. And in fact, it might even be carriage return and line feed. I'm not 100% sure. How about, just for simplicity's sake, let's say it's 1, 2, 3, 4, 5, and then whatever the new line sequence is on your platform. And so the barcode will come in, again, as a string, and you need to send text somewhere that represents the price, a text representation of the price. How you make that happen is completely up to you, but I'm going to give you a couple of little hints. One simple thing that you could do on the output side is keep track of the last text displayed and check that. This is the thing that you can check in tests. So you can think about how you would structure that in whatever language you're going to work in. It'll be a little bit different with an object-based language than it would be in a functional language. The other thing I'm going to mention is on the input side. I have seen over and over and over and over again people write code that has the thing they build talking to something called a barcode scanner. No, no, no. This is a bad cyclic dependency. In fact, this completely misses one of the most basic points of good modular design. I recommend that you design this in a way that receiving the barcode is modeled like an event. And you don't care where the barcode comes from. You don't care how to get the barcode. You don't care why the barcode is here. All you care about is that you've received a barcode. So you can expose a method. In Java, we would call it onBarcode, and it would take a string, and it would return nothing, because event handlers never return anything. In part because the whole notion of event-based programming is clients fire events at you, and then they forget them. And something happens, and it makes them happy, and maybe they get a notification back later, but in this case, we don't even need to worry about that. So the outside world is going to send us a barcode, and all we have to do is react to it. So don't build something called a barcode scanner. Whatever it is that you build in the middle here, all you care about is exposing a method called onBarcode, or whatever the corresponding convention is in the language you're going to work in. It takes the barcode as a string and returns nothing. So in particular, I don't ever want to see a test where you call onBarcode, it returns a result, and you check that result. That's going to be a constraint that I'm going to put on you rather intentionally. OnBarcode returns nothing. It's an event handler. Event handlers don't return anything. Event handlers make something happen. And by the way, throwing an exception is really just a fancy way of returning something. So that's the overall feature. You want to sell a single item, which consists of receiving a barcode and displaying the correct price on the display. So here are your instructions. It's really simple from here. Step 1, write a test list. This is another feature similar to adding fractions where there's a single operation on barcode, but multiple special cases. What do I do if the barcode looks like this, if it looks like that, if it looks like the other? So write a test list, think about the special cases that you're going to have to deal with. The second thing I want you to do is TDD a solution. Focus on the 2 simple rules of TDD that you would have read by now at Ward's Wiki, the original Ward's Wiki page on test-driven development. Right? There are 2 basic rules. Let's take a quick look. Add a test, get it to fail, and write code to pass the test. That's step 1. And step 2, remove duplication. Focus on these 2 things. Apply these 2 steps as strictly as you can. Even if you think that you've done this a million times before, you could probably be even stricter. Don't write any code without a failing test, and remove as much duplication as you can. Now, after you've test-driven the solution, publish your solution somewhere. When I say publish your solution, I don't mean the final solution. I mean publish your solution and commits. So, for example, you might send this all to GitHub, and then go to the discussion group and say, hey, I'm done. Here's my code up on GitHub. Then the next thing I'd like you to do is to pick someone else's code to review. Now, I'm going to leave that instruction pretty open and vague. Make whatever comments you want. It might be easy. You can decide whether you want to make those comments as GitHub comments on the project or on an individual file or on an individual commit, or if you want to make those comments in the discussion group. I would recommend making the comments over in GitHub and then putting a message in the discussion group pointing there, saying, hey, I reviewed code at such and such. Anybody who wants to review my comments, feel free. And if you want to record yourself performing your solution, then grab your favorite screencasting software and Camtasia or ScreenFlow or whatever you like to use, and have at it. Record it, upload it to Vimeo or YouTube, and we'll be happy to take a look at it. So that's your exercise for today. Go get them. Thanks very much for listening, everyone. Hope you had a good time. I hope this is going to be fun for you. And if it's not, well, that's your fault. Thank you. Until then, this is goodbye from JBrains.